our previous video with the second derivative test, let's put this to work classifying critical points. So the function that we're going to be looking at is f of x is 2x minus x squared times e to the x. So if we crunch things out, we know we need both the first and the second derivative. So I'm going to gloss over the steps. We'll be using the product rule to do this. You can check the steps for yourself. The first derivative is 2 minus x squared times e to the x. The second derivative is 2 minus 2x minus x squared times e to the x. To find critical points, we know that we're going to have to set the first derivative equal to 0. Note that the first derivative is never going to be undefined, so it's only when it's equal to 0. So let's see, e to the x, that's never going to be 0. So really, this is asking when is 2 minus x squared equal to 0. So x squared is equal to 2. So we get 2 critical points. X is plus or minus the square root of 2. So we got 2 critical points. Now let's use our second derivative test to classify them. So what we're going to do, we're going to evaluate f double prime of root 2 and f double prime of minus root 2. So we plug in root 2 up in here and minus root 2 up in here. We observe that the f double prime of root 2 is minus 2 root 2 e to the root 2, and f double prime of minus root 2 ends up being 2 root 2 e to the root 2. Now we don't actually care about the exact values as before. We just care that this is negative and this is positive. So what do we see here? Negative second derivative corresponds to local max. Positive second derivative corresponds to local min. So we conclude that x is equal to root 2 is going to be a local max, and x is equal to minus root 2 is a local min. Okay, so that's an example which everything works out. Let's do one more example just to illustrate that inconclusive case actually does happen sometimes. So suppose that we're thinking about g of x is x to the 5th minus 5x to the 4th. So as before, we need a couple of derivatives. 5x to the 4th minus 20x cubed. And g double prime of x is 20x cubed minus 60x squared. So in order to find our critical points, we set this equal to 0. We can factor out x cubed and factor 5x cubed. So 5x cubed times x minus 4 is equal to 0. So we get critical points. X is equal to 0 and x is equal to 4. These are our critical points. So what we have to do now is let's plug in 0 and 4 into our second derivative in order to classify. So if we plug them in, g double prime of 4 ends up as 320. That's positive. So that tells us that because our second derivative is positive, x is equal to 4 is a local min. However, g double prime of 0, and we plug that in, we get 0. And so this is our final case here, that we have something that's inconclusive. It might be a local min, it might be a local max, or it might be neither. So the second derivative test fails. It's inconclusive. So what we have to do is that we have to resort back to our first derivative test. So let's just choose some values on both sides of 0. And we're going to plug those values in, not into the original function, not into the second derivative, but into the first derivative. So if we check that, if we look at g prime of -1, that ends up as 25. If we try g prime of +1, that ends up as -15. So the first derivative test is going to rescue us. We see the derivative is changing from positive to negative, and so that means we have a local max. So moral of the story here, even if our second derivative test is inconclusive, we can use the first derivative test to save the day. So the second derivative test is probably easier to use, but the first derivative test might work in a few more cases. So I think that's a good moral of the story to end things on. And to wrap up the set of videos, here's a second pre-class problem and just have you practice doing everything that we looked at in the set of videos.